Afternoon, welcome to a chemistry session. It's a chemistry session, and as we understand, chemistry has 5 main branches. That is the branches of chemistry, largely branches of chemistry. There are mainly 5 branches. That is branch number 1, that is what we call the biochemistry. Branch number 1. Branch number 2, we have what we call analytical chemistry. Branch number 3, we have physical chemistry. That is our branch number 3. Then branch number 4, we have organic chemistry. Then lastly, the last branch, that is what we call the inorganic chemistry. Now, these branches are learned at both advanced level, basic level, tertiary level, depending on the level of the studies. Now, today, we want to take one branch of chemistry to go through it. Each branch has its topics. Biochemistry has its own topics. Analytical has its own topics. Physical has its own topics. Organic chemistry is largely taught as organic chemistry. You don't have topics under it, but organic has several topics, including industrial chemistry, the industrial processes, the gases. They are under inorganic chemistry, even including the salts. So today, we shall take a look at the analytical chemistry, and under that we shall have one topic, that is topic 1, analytical chemistry. Same topic is taught in high school. Also, it is taught in advanced level, that's second year. When you are doing pure chemistry, you will meet a topic called electrochemistry. So under analytical chemistry, kindly let us look at a topic called electrochemistry. So electrochemistry is our first topic. Electrochemistry. That is under analytical chemistry. Now, under electrochemistry, it has a backbone. For you to understand electrochemistry, you must understand something called what we call the redox reactions. Redox reactions, that is the backbone of this topic called electrochemistry. So before you do anything in electrochemistry, you must understand what is redox reaction. Now, redox reaction comes from two words. Number 1, you have what you call reduction. Number 1 is reduction. Number 2 word is oxidation. Oxidation is second word. So these two words, you take red, then you have ox. So now we shall have what we call the redox. Now, what is a redox reaction? What is a redox reaction? Now, this is a type of reaction whereby two reactions are taking place at the same time. What do we mean? For example, substance A is reacting with substance B to give us substance C and D. At the same time, substance C is reacting with D to give us A and B. This reaction is taking place simultaneously. at the same time. So you have the forward reaction or the backward reaction, all of them taking place at the same time. So that type of reaction, that's what we call the redox reaction. Now, from there, we want to see now what is reduction and what is oxidation. Now you have understood the complete reaction is called the redox reaction. But now I want to split it into two. What is reduction and what is oxidation? And what is oxidation? Now we shall have some small formula called oil rig. Oil rig. This is what we simply oxidation is losing. Then reduction is gaining. Oxidation is losing, reduction is gaining. Now, so a substance or an ion or a compound which normally undergoes oxidation, that is, it will be losing an electron. For instance, when we take chlorine gas, this chlorine gas, it will give us chloride ion. So in this case, chlorine has gained one electron to become negative. It has gained one electron to become negative. So in this case, chlorine has been reduced from 0 to 1. Because if it is a molecule or a gas, it has an oxidation number of 0. But now the ion of chlorine has become negative, meaning from 0 to negative, chlorine has lost. It has gone through oxidation. That is it. Then another example, we have sodium, that is sodium metal. Sodium, for it to become stable, sodium will lose one electron. Because sodium is number 11 and its configuration is 2 to 8 to 1. So this sodium, for it to become stable, it must lose this one electron and it will become sodium ion. So it was 0, now it has gained to be positive. So in this case, sodium has undergone through oxidation and sodium has lost 1. So when you lose electron, losing, you become oxidized. When you gain electron, you become reduced. Combine equation for 2. That's for sodium. We had that sodium and chlorine. This sodium chloride is a salt. So these two, when they undergo ionization, they'll give us sodium ion and chloride ion. This is chlorine. Now in this case, sodium is a plus, Sodium, it had an oxidation state of 0, now it is positive. So sodium, in this case, has lost an electron. And chloride, in this case, has gained an electron to become negative. So this sodium, this is now, it has undergone what you call oxidation. and chloride has undergone what you called reduction. They are taking place at the same time. So oxidation is losing. Sodium has lost 1 to become sodium ions. Chlorine has gained 1 to become chloride ions. So when chlorine is gaining, that 1 is being reduced. So chlorine has been reduced. It was 0, it is now negative. That is a drop. Then sodium, it was 0, it is now a positive. That is an increase in number of oxidation numbers. So sodium has undergone through oxidation, and chlorine has undergone through reduction. Then we have what you call we have the reducing agent. We have what you call a reducing agent, and we have what you call an oxidizing agent. A reducing agent, oxidizing agent. Now, a reducing agent, in most cases, it is an agent which is normally oxidized. Then an oxidizing agent is an agent which is normally reduced. Still using the same example, you can use this one. The same example, iron 2. If it is oxidized, it will give us iron 3. It was 2 positive, now it is 3 positive. So you have an increase in 1 electron. So iron 2 has been oxidized to iron 3. Iron 3 can still be reduced to iron 2. So in this case, when iron 2 is being oxidized to iron 3, iron 2 is a reducing agent. And when iron 3 is being reduced to iron 2, iron 3, that is an oxidizing agent. Now, how do we get these oxidation numbers? Someone might ask. Now, that one will link us to our next session, whereby we shall be calculating oxidation numbers of atoms in a molecule. Atoms in a molecule. For example, you'll be asked a question, or you find somewhere, this one is called sulfuric 6 acid. Where is the 6 in this compound? Why can't you say sulfuric acid? We must put the sulfuric 6 acid. Or acidified potassium dichromate 6. Acidified potassium dichromate 6. So we want to see where are those 6 coming from. Now, for us to do that, we shall have a session whereby we shall go through rules used to assign oxidation numbers. Why is it called dichromate 6, manganate 7, sulfuric 6? That is whereby we have more than 10 rules used to assign oxidation numbers to compounds. From there, we shall now have an idea, or know, this is why it is called nitric 5 acid. That 5 must be calculated using the rules that we shall have in our next session. Meanwhile, so from there we shall, after doing those rules and more calculations and more example, we shall start from there in our next session. Otherwise, have a good time. Continue subscribing to our YouTube channel for more classes